Okay, this is lesson 7 of unit 3, combining the laws of logarithms. If you review this is what we learned basically in the last lesson: the product law, the quotient law, the power law. So you can stop the video here or look at your textbook and just review these log laws. In this lesson we're going to be studying examples which combine the power law with the product and quotient laws. Okay, in example 1 it says here to recall class example 5 from lesson 6 shown below. And we do that. It says determine the value of 3 log p base 2 minus 3 log q base 2 if p over q is 8. So it says show how this problem can also be solved using a combination of the laws of logarithms without removing a common factor. So before we probably removed this common factor of 3 and 3, and then had a log minus a log, which we ended up having a log of p over q, and we replaced 8. But a different way to do it is to bring the 3 up as an exponent in both these cases, and we get the following. So looking at that, again it's a log minus a log, and it's a log of this minus a log of this. So this is what ends up as the quotient, p3 over q3, and we can take the exponent out because it's common to both. Well, we know p over q is 8, so this here, the exponent is brought forward, and we get this, and substitute 8 for p over q. Now we can write 8 as 2 to the 3, and we know log 2 base 2, if we have the exponent like this value here for all of this is actually equal to the exponent 3. So we end up with 3 times 3. Looking at it like this, we can bring this exponent to the front, and it would be 3 times 3 log 2 base 2, or 3 times 1. So again we get the same values we did last time in the last lesson. Okay. Example 2, use the laws of logs to write a half log 16 minus a third log 8 as a single logarithm. We're using base a here. Well, we can bring these numbers up to exponent form up here with the 16 and with the 8, as we see here. Now, because it's one log minus another, we're using the quotient. We can actually square root if we want right this minute, and cube root 8 to the 1/3 is a cube root, and we get 4 and 2, 4 and 2. So this will be 4 over 2, which is just 2. So it's log 2 with base a. Evaluate a if we have problem a if we have a equal to 32. So this is a base of 32. So writing it like this, log 2 base 32. Remember, if we use this, we can do change of base, where we can make the base anything. In this case, since it's not mentioned, it's base 10. So it's log 2 over log 32. In our calculators, we can do that, or we can simply change this to log 2 over. Now remember what 32 is. Since this is a clue, we're using 2's as the base, not as the base number, but 2 to the 5 is our exponent. So 2 to the 5 is 32. Well, this 5 can be brought to the front, and so it's log 2 over log 2 times this 5. We put it out here, so it just ends up being 1 over 5. Evaluate the following without the use of the calculators. Example 3. So again, we get 2 logs, and we're subtracting, so we could use the quotient rule. Let's bring this 3 up here, and now we have a log minus a log. I'm just looking at what they have down here. They're going the opposite way, but if I do that, I'll do it a slightly different way, where I bring the 3 up. So I'll have a single log, and I'll have x to the 3 over x to the 3. Now we all know that's really 1, so I'm evaluating log 1, and log of 1 is 0. Plug that into your calculator, you can double check that. Or you can see the way this has happened here. These are identical, you didn't even really have to go through this step. But it's one way to prove, in a sense, that log 1 is 0, because 3 log x minus 3 log x can be written, when we bring the exponents up here and up here, it can be written in this fashion here. So really log of 1 must be 0. Okay, what about this one? Well, log 5 and a log 2, we can bring the 2's up as exponents here. We get the following, and that's really log 25 plus log of 4. Okay, why do we want to do that? Well, you can have kept 5 to the 2 and 2 to the 2 if you wanted to, and then just this becomes the product law when you're multiplying 25 times 4. So this becomes really a log of 100. Log of 100 is 10 to the 2, and we're really dealing with base 10, so this whole thing becomes 2. But this is a very common log. You should realize log of 100 is 2, log of 1,000 is 3, log of 10,000 is 4, and so on. And here we have 27 to the 3 over 81 to the 4, and it's base 3. So I'm wondering if we can use the fact that this is 3 to the 3 to the 3, so I'm not sure if we want to write it like this right now. 3 to the 3 to the 3, and 81 is actually 3 to the 4 to the 4. I would simplify this right now and find that this is really 3 to the 9 over 3 to the 16, and take it from there. However, it shows probably a slightly different way of doing it here. We're making splitting them apart now, that it's a difference of 2 logs instead of the quotient, and then bringing the 3 out front and the 4 out front gives us this, and looks like we are changing the 27 to 3 to the 3 and 81 to 3 to the 4. We can now bring these forward, so that becomes 9, that becomes 16. Here we are, 9 and 16 here and here. And then finally, notice these are both log 3, so 9 log 3 minus 16 log 3 is negative 7 log 3, and log 3 to the base 3 really is 1, so this whole thing becomes 7. It would have worked out this way too. We would have got log 3, and that would have been 1 over, because you get 3 to the 9, 3 to the 12. Remember to subtract. Sorry, I'm just going to erase this. We would have got 3 to the 9 minus, oh, this is 16, 9 minus 16, sorry, is negative 7. So that's where we can get the exponent as the answer, negative 7. So there's more ways to skin a cat in math than we know what to do with. Okay, so log x base 2 equals a, determine an expression for log 16 x squared base 2. Now remember, we cannot bring this 2 forward because the whole thing is not squared. 16 is not being squared, only the x. So we can split this up into log of 16 and log of x squared, which we're doing here. The 2 can now be brought forward in front, and this 16 is really 2 to the 4. 2 to the 4 can also be brought forward, and we get the following. This really, log 2 base 2 is 1, so 4 times 1. And I am just looking to what this is. This is x. Now they tell us that log x base 2 is equal to a. And that's exactly what we've got here. We've got 2 of them. So we really have 2a. So that's what we have here, 2a. So we're dealing with 4 plus 2a as our answer. Okay, last example, and it says write the following expression as a single log. Log b plus log d equals minus 5 log e minus log a squared plus a half log a. So just use the quotient and product laws, remember all positive logs can go on top. In a sense, I'm not even going to follow this because it's one method, you can look it over. I am going to write this as a single log. If I can get rid of the screen of blue. Okay, selecting the pen. We will have a single log with b on top, because this is a positive log. So is this one. So we have b on top. We have times d. We have a negative. Now this 5 really should come up here, leaving the negative below. So we'll have e to the 5 on the bottom. This is negative, so a to the 2 is on bottom. This is positive, so we can have, I'd bring the half up here first. We'll have a positive a to the half on top. The only thing we can simplify here are the a's, or leave it as is. We can change it to, in fact, this answer right here, where the half, take a half away from here, cancel a half here, and you're left with just 1.5 or 3/2. So if you can do all the questions, that would be great, and we'll see you in class.